The dual clutch transmission has a two-part main shaft consisting of an inner and outer shaft. The gears are arranged on these two main shafts with the odd-numbered gears on the inner shaft and the even-numbered gears on the outer shaft. The first clutch supplies power to the odd gears, and the second clutch supplies power to the even gears. Now, explore the operation of the DCT on your own. Click the up and down buttons to manually shift the transmission. A separate lubrication circuit supplies oil to the DCT. A third rotor is added to the oil pump, along with a separate filter for the DCT oil supply. This DCT oil filter is fitted here on the right side of the engine. Oil from the DCT oil pump supplies oil pressure through solenoid control valves to both clutches. The DCT system is designed to engage the clutch just as an experienced rider would. As the first clutch releases pressure, the second clutch is engaged in steps. A little pressure is applied to close up the clearances between plates, then a little more pressure is applied to engage the clutch, and finally, more pressure is applied to ensure the clutch doesn't slip. Now, let's have a closer look at how the clutches operate. Oil pressure from the DCT pump passes through the filter and solenoid valve and enters the clutch. Higher DCT oil pressure is applied to the clutch pressure plate to engage the clutch. Lower engine oil pressure is also supplied to disengage the clutch. The use of engine oil pressure to disengage the clutches ensures that they will release quickly. The PCM contains two CPUs that monitor each other. If an abnormality is detected from one CPU, the other CPU switches to fail-safe mode and the indicator light switches on. The VFR1200F uses a single PCM to control PGM-FI, throttle by wire, and the DCT. The PCM also receives rear wheel speed information from the ABS system. Separate oil pressure sensors monitor the DCT oil pressure before and after the clutch control solenoids. Sensors also monitor the shift spindle rotation, transmission range of the shift drum, and speed of both the inner and outer main shafts. The drive shaft is offset below the swing arm pivot. This allows the swing arm pivot to span the full width of the frame, giving greater strength and rigidity. A side benefit of this layout is a decrease in squat and lift with changing throttle position. The drive shaft is attached to the engine output shaft with a circ clip that must be removed before removing the drive shaft. A constant velocity joint is fitted at the back of the drive shaft to take up changes in drive shaft length as the suspension moves through its range of motion. Be careful when removing the drive shaft to prevent damaging the CV seal. The new final drive gear case is smaller and lighter than previous models. Check the gear oil level with the VFR on the side stand. When draining the gear oil, slowly rotate the rear wheel to drain all of the oil. The gear case is sealed and has no breather. The VFR's combined braking system with ABS melds the benefits of ABS with the measured application of the front brakes when the rear brake lever is applied. During front brake lever activation, all 6 of the right side caliper pistons are applied, along with 4 of the pistons on the left side. When the rear brake is applied, the other 2 left side pistons are actuated. To maintain equal braking force when using just the front brake, the 3 right side pistons are smaller than the 2 left side pistons. A parking brake is fitted to the VFR1200F DCT model. To engage it, pull back on the handlebar mounted lever. To release the brake, push in on the release button while pulling back slightly on the lever. The fairing on the VFR1200F is very easy to remove. It uses a new type of retainer clip that engages this rectangular hole and locates the panel very accurately. To remove the middle cowl panels, first remove the fasteners located here, and inside the front of the fairing. There are 3 Allen head screws and 4 clips to remove. Then, pull the back edge out and push the cowl forward. Installing the fairing middle cowl is almost as easy as removing it. You'll need to line up these 2 fins, the top and bottom edges at the front, and line up this clip. Then, just push it back and on. It's very easy to do after a little practice. The fuel tank covers are held on with a clip at the front, a clip on the black lower panel, and an Allen screw at the rear. Under the covers are 5 small pads with locking pins that engage with similar pads on the tank. These 4 pin pads can move out of position when the covers are removed. Be sure to reposition these before reinstalling the tank covers. With the fuel tank removed, you can see the air filter case and the heat shield over the rear cylinder head. Remove the air cleaner cover and base, then remove the throttle bodies. The throttle body intake clamps for cylinders 1, 2, and 3 are accessible from the left. Cylinder 4 is accessible from the right. You can reach them with a long screwdriver. Be sure to cover the intake ports after the throttle bodies are removed to prevent something from falling into the intake ports. Valve clearance inspection and adjustment can be done once the head covers are removed. Exhaust clearances can be measured at the valve stem or at the cam follower. Checking the front cylinder head exhaust clearances at the cam follower is easier to do from the rear. Note that there are different clearances for these 2 inspection locations. We found that the first time we did a valve service on the VFR, removing the radiator gave much better access to the front cylinder head. You don't have to do this, but it does make it easier to access the exhaust adjusters. A small screwdriver can be used to release the cam chain tensioner by prying up on the top of the cam sprocket. Then, fit a wire in the adjuster to lock the cam chain tensioner. The sprocket can be left in the chain when the camshaft is removed. After changing the intake shims, you'll need an extension like this to torque the cam sprocket bolts during reassembly. The bolt sizes used on the new VFR1200F engine crankcases now include 6, 7, 8, and 9 mm sizes. The 9 mm bolts used at the main bearings are made from high-strength steel and have a special coating. Don't clean them. They should be installed just as they come from the parts package. Just like those used on many of Honda's newer engines, these bolts are tightened using the plastic region or angle torque method for a more consistent clamping pressure. When reassembling any Honda engine, be sure to check the service manual for the bolt tightening torque. If you see a torque spec like this one, be sure to tighten the bolts with an angle torque adapter. These bolts are tightened to 25 Newton meters and then 270 degrees of rotation for the manual transmission, and 150 degrees for the DCT model. The connecting rod bolts also use the Newton meter plus angle tightening procedure. The cooling fan on the VFR1200F will operate when the engine is running and the coolant temperature is above 50 degrees Celsius or 122 degrees Fahrenheit. This prevents heat from deforming the plastic fairing parts near the exhaust. The coolant level can be checked by lowering the hinged engine heat shield that covers the coolant reserve tank on the right side to the rear of the engine. Make sure to inspect the coolant level with the motorcycle upright. The throttle-by-wire drive motor will occasionally make a slight whirring sound when the key is on and the engine is stopped. This is normal. The VFR's accessory trunk is designed to move side to side. Be sure to test it after it's been mounted to make sure it can move freely.